Imagine a perfect box. You pull out every atom of air, every photon of light, every single particle of matter and radiation. What is left inside? For 2,000 years, the answer was thought to be simple: nothing, an absolute void. Modern physics has discovered something else entirely. It is found that nothing is the most active place in the universe. In the ancient world, the question of empty space was a purely philosophical battle. Aristotle, around 350 BCE, famously declared that nature abhors a vacuum, that a true void could not exist. Opposing him were the Greek atomists, who imagined that particles had to move through an empty void. But all of this was speculation, a debate in the mind. The truth had to wait for the 20th century, when physicists finally gained the tools to look at empty space with the precision of quantum mechanics. What they found did not just settle the old debate, it broke the old idea of emptiness forever. There is no such thing as truly empty space. To understand why, you need a new picture of what space actually is. In modern physics, it is not a passive container, it is a stage, and on that stage, quantum fields are always active. Every type of particle you know, from electrons to photons to quarks, corresponds to a fundamental field that exists everywhere in space, at every point. And here is the strange part. Even at the lowest possible energy level, what we call the vacuum state, when no real particles are present, those fields are not still. The Heisenberg uncertainty principle, formulated in 1927, forbids them from being perfectly silent and motionless. A field cannot have both a perfectly defined value and a perfectly zero rate of change. So instead, they fluctuate. Virtual particles, pairs of matter and antimatter, boil out of the background energy, exist for an immeasurably short time, and then annihilate. The vacuum is a seething ocean of this potential, an activity that cannot be turned off. This is not just a theory. In 1948, the Dutch physicist Hendrik Casimir predicted a tangible effect. He calculated that two perfectly parallel metal plates, placed just nanometers apart in a perfect vacuum, would feel a tiny but measurable force pushing them together. The cause? The sheer number of vacuum fluctuations outside the plates is greater than the number that can fit in the tiny gap between them. This imbalance creates a real pressure. The Casimir effect was definitively measured in 1997. The empty space pushed. Think about what this means. What we call absolute nothingness has a definite structure. It has energy. It follows strict rules. It can exert a physical force. The vacuum is not the absence of reality, it is the ground state of reality, a system that cannot be made to stop existing. And the implications get even stranger on a cosmic scale. In 1998, astronomers studying distant supernovae made a startling discovery. The expansion of the universe is not slowing down, it is accelerating. It is being pushed apart by an invisible energy that fills all of space. They called it dark energy. It accounts for about 68% of all the energy in the cosmos. While its true nature is one of the deepest mysteries in science, most physicists suspect that this dark energy is somehow the energy of the vacuum itself. The simmering emptiness of space is what is pushing the galaxies apart. And this reveals the core thesis of this series. Reality is not built from substance, from little bits of matter. It is built from structure, from information, from the rules that govern existence. Even the absence of matter is a profound structure. Nothing, in the deepest sense, simply does not exist. Next week, the strangest connection in physics. Two particles that act as one across any distance. Quantum entanglement. Subscribe to Synapse Bytes. We continue.